In this video, we're going to write this sum down in sigma notation. So, first step, we're going to need to think about where to start our sum. Well, I like to start sums at 1 or 0, and first time through here, I'm going to say let k equal 1. And then I have 1, 2, 3, 4, 5 terms, so this will be a sum from 1 to 5. Now it's just our job to figure out a kth term formula. So the first time through, when k is equal to 1, I'm supposed to get out 1/5. Next time, when k is equal to 2, I'm supposed to get out 2 over 25. And I think I see a large part of the structure here. So when k was 1, there was a 1 on top. When k was 2, there's a 2 on top. And I see that carries off. So I think I have a fraction. I think I just have k on top. And then on the bottom, I see 5, 25, 125, 625, 3,125. And well, that's 5 squared, 5 to the third, 5 to the fourth. And this is 5 to the fifth. I recognize these ones, and I checked that one just to be sure. Well, that's 5 to the first when k is 1, 5 to the second when k is 2. So the bottom of these fractions appear to be in the format of a 5 to the k power. And then I realized that every other one of them has a minus, so I need to think about a way to make this sum alternate. So I know some of the terms have a -1, and all I have to do is raise that -1 to the k power, because when I raise -1 to an odd power, well, that will be a -1. When I raise it to an even power, it'll be a positive. So this sum formula will actually generate exactly the sum I'm looking for. And that's a perfectly fine final answer. But since I have two things raised to the k power, I could write that as a -1/5 all to the k times k. And that's just a little bit nicer, but there was nothing wrong with that. So I thought we'd do this one twice, because I did say that sometimes it's nice to start sums at 0. So there would be a 0 term, a first, second, third, and then finally fourth. Because when I throw a 0 in there, between 0 and 4, there are 5 things. And, well, the same patterns emerge. There's a 5 to a power on the bottom. It's now just a k plus 1 power. Or if I think about it, when I plug a 0 in, it wouldn't work anymore because that'd be 5 to the 0. I'd get a 1. I need to add 1 to it, so I get 5 and then 25. And on up, same thing on top. I get a k plus 1 rather than a k. And I still need to make this alternate. And the same thing happens where it has to be a k plus 1, so that when I plug 0 in, I get a -1 to the first is negative. And then when I plug a 1 in, -1 to the second is positive. And so there are two different ways of writing this sum down in sigma notation.